Hi, this is Algebra 1, Module 4, Lesson 3's practice problems. I'm going to go through a few of these with you just to kind of make sure you're on the right track in case you needed some help going through them. Um, we'll talk through each of these first ones in our Ready section because this is kind of a newer thing. Um, so they give us an equality, -9 is less than 2 to complete each row in the table. So -9 is less than -2. That is true. So we're going to see if we do some of these operations with each of them, what happens. So if I add 3 to both sides, for example, -9 plus 3 is -6. 2 plus 3 is 5. Is -6 still less than 5? Yes, that's true. So let's try it when we subtract 7 from both sides. So if I have -9 minus 7, is that still less than 2 minus 7? Well, we come over here. -9 minus 7 is -16. Is that still less than 2 minus 7, which is -5? Yes, I would consider that true. So let's go ahead and just put true over here. Okay, next one. Add 15 to both sides. So I'm looking at -9 plus 15. Is that still less than 2 plus 15? Well, -9 plus 15 would be a positive 6. Is that less than 17? Yes, that is true. And that over here is true. Okay, so far we're working out with these. Let's see if I can squeeze that up a little bit. All right, so this next one, stick it right here. Add a -10 to both sides. So -9 plus -10, is that less than 2 plus -10? Well, -9 plus -10 is -19. Is that less than 2 plus -10, which is -8? Yep, we're still, so far this stuff's looking like we can do these things. So adding and subtracting seems to keep everything true. Let's try multiplying and dividing. So if I multiply both sides by 10, I'm taking -9 times 10. Is that still less than 2 times 10? Well, -9 times 10 is -90. Is that less than 2 times 10, which is 20? Yep, -90 is less than 20. So we're still looking at true. Um, this next one, divide both sides by 5. So -9 divided by 5, not less than 2 divided by 5. Well, okay, so -9 divided by 5 is -1.8. Is that less than 2 divided by 5? Well, that's a positive number, so probably, but that's 0.4. So yes, 0.4 is bigger. Okay, multiply both sides by -6. So notice how we're testing each of these. We've added to both sides, we've um, added to both sides, subtracted to both sides, added a positive, added a negative, multiplied a positive, divided a positive. Now let's multiply a negative. So -9 times -6, is that less than negative, wait, no, 2 times -6? Okay, -9 times -6 is a positive 54. Is that less than a -12? That is not. So these negatives are going to throw this off a little bit. We need this information as we're going forward. Okay, so let's see if that's true with the division too. -9 divided by -3 Is that less than 2 divided by 3? Negative 9 divided by 3 is a negative 3 is a positive 3. Is that less than 2/3, which I'm just going to leave as 2/3 because that's a fraction? No, 3 is bigger than 2/3. So that is actually false as well. Notice how we were doing okay until we hit these negatives. The negatives, multiplying and dividing by negatives, throw off our inequalities. So just note that for as we're moving forward. Um, oh, what operations were performed on an inequality reversed the inequality? So just what we were saying. When you multiply or divide by a negative number, the inequality needs to be reversed, right? Because it's no longer less than, 3 should be greater than. So it actually would flip our inequality symbol at that point. Okay, so all these we are solving for our variable. I'm not going to do all these because we have been doing lots of these lately. I am going to pick a couple to do just to help you practice them. So to start with, let's see, all of those, they do have multiple variables. Let's do 13. We'll do 13 for one of them. So solve for z. We want to solve for this guy. So work my way towards z. 3 is on the outside. Let's divide by 3. So z plus 7 equals a over 3. To get rid of a plus 7, I need to subtract 7 minus 7. So z equals a over 3 minus 7. So 2 steps on that one. All right, let's do, we did one with parentheses. Let's do this one without parentheses. Let's try 18. It looks a little more complicated. So I want the x by itself, solving for x. So I need to start with adding 9y. It's not showing up very good. Let me try that better. Plus 9y plus 9y. Those cancel. So I have 2x over 5 equals 6 plus 9y. Now, I have that fraction again, so I'm going to times by 5 over 2. Working times 5 over 2. So I can actually put this together, and I'm going to do x equals, so I'm going to take this and I'm going to go ahead and distribute this time because I might end up with even numbers. Let's see what happens. So 5 times 6 is 30, plus 5 times 9 is 45, all over 2. Oh, 45y, sorry. So I can actually simplify the 30 divided by 2, right? We have a number for that. So x equals 15 plus 45 divided by 2 is not as nice. So I'm just going to say 45 over 2y. So just wanted to show you how on another lesson we just left it all in parentheses because we couldn't simplify anyway. Here I'm showing you you can simplify. So we'll go ahead and distribute that 5. Go ahead and distribute this 5 to each of them so that then we can divide at least this one by 2. So just some practice on those. Go ahead and work on the rest. We've been doing these for the last now 3 lessons, so lots of practice for those. All right. On this guy, we have identify the x-intercepts and y-intercepts. So x is when y equals 0, and the y-intercept is when x equals 0. So again, this should be review. We've been talking about these before. But y equals 0 here, so that would be an x-intercept, so at 2, comma 0. And x, yeah, we'll use a different color. Let's use a different color. We did the y in blue. Let's do x in green. So the x-intercept is when, I did that backwards. Let's erase that. Okay, the x-intercept we're going to put in blue. Yeah, when y equals 0. And so the y-intercept, no, I did that right. Y-intercept is when x equals 0. And so that's at 0, 4. Okay, so here, where does the y equal 0? Or sorry, for the y-intercept, x equals 0 at 0, negative 6. And the y equals 0 right here at 18, comma 0. And again, x-intercept is when y equals 0, 2, comma 0. Remember, we always start with that x value. The y-intercept is when x equals 0, so 0, comma 4. All right, let's keep that theme going. Locate the x-intercept and the y-intercept on the graph. So we're doing x in blue and y in green. Okay, so let's go ahead and just keep with our color scheme. So got green going here. So y-intercept is right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, comma 9. X-intercept is right here. That's at 3, comma 0. Over here, we'll start with the x-intercept. 1, 2, 3, negative 3, comma 0. Y-intercept right there. 1, 2, 3, 4. 0, comma 4. So just keep track. You know which one is supposed to have the number first, which one's supposed to have the 0 first. It's an x-intercept. We should have the x value first. Next page. Again, I'm not going to do all these, but I'll get you started. So here it says solve each equation for x, provide justification. So which property of equality do you need? So right here, to get rid of a minus 6, we have to add 6 to both sides. So it's an addition property. To get rid of a times 3, we have to divide by 3. So that's a division property. Justification would be, never mind. This is the next problem. I thought we had to solve to prove it worked. Because 3 times 7 is 21. 21 minus 6 is 15. So you can always double check. Let's just pick a couple to do. I'm going to jump down to 29 and 30. How about 29 and 32? That way you get one each of the more complicated. So first, we are going to get all of our numbers to one side and all of our letters or x's to one side. So I'm going to subtract an x from each side, and I'm going to subtract a 3 from each side. And this is going to be a subtraction property because I'm subtracting both of them. So 6x's minus 1x is 5x's. Positive 3 and minus 3 cancel. Positive x minus x cancels. 18 minus 3 is 15. So now I'm left with 15, 5x equals 15. To undo a times 5, I'm going to divide by 5. So that's a division property. And that leaves me with x equals 3. So that's how you can do that. If you would have done this row in 2, you would have had 2 subtraction properties. subtraction property for the x's, and a subtraction property for the 3's. So you can choose how you do that. Let's do 32 since we have a couple of letters involved here. So first, I'm going to divide, let's see, I'm solving for x. I'm solving for x. So let's get rid of everything in our parentheses. How do I get rid of a parentheses of b plus 7? Well, there's a multiplication between there, so I'm going to divide both sides by b plus 7. And if I'm dividing, it's the division property. These cancel. That leaves me with x equals 9 over b plus 7. That's all I had to do for that step. There's actually only one because everything else was in parentheses besides our x. So big thing is just making sure whatever operation you're doing, that's what the property is. Thanks for joining us, and we will see you next time.